This is 2.5 part 3, and in this question we're going to be dealing with word problems. The word problems in this section actually aren't terribly difficult because you just need to picture yourself in the situation and draw it accurately and you'll be fine. So Miss C's calculus class was done outside of the school. This is actually my calculus class. And we were out there for a Halloween class picture. A few kids are missing. One of the ones that dressed up were in there. Miss C looked up at an angle of elevation, she's over here, of 67 degrees. So she looked up and she saw a UFO approaching the school. If the UFO was at a height of 231 meters, how far is the UFO away from Miss C along her line of sight? So a bunch of questions here that you have to answer. You have to understand the language of it first of all. So here's Miss C, and she's standing on the steps of the school, and the other kids are all around behind her. Oops, you can't even see that. So there she is. So when we're talking about an angle of elevation, the first thing you need to remember to draw is a horizontal line. And we're not going to take Miss C's height into account, just like we haven't in any other questions, because she's pretty short. So she looks up at an angle of elevation of 67 degrees. So there's an angle of elevation, and that's going to be 67. And she sees a UFO. Now I don't know how to draw UFOs, so it kind of looks like that. Pretend. It says the UFO is a height of 231 meters. Someone's height or something's height is how high it is directly straight down from it to the ground. So if this UFO was to fall, it would fall along this path right here, and that's going to be 231 meters. Question is, how far is Miss C along her line of sight? A line of sight is always the line between where the person is and what they're looking at. So in this case, we're going to call that X. That's her line of sight. So our first step after that is to fill in your triangle, what you know. Here's your angle. Here is your hypotenuse. And here is your opposite side. Let's label it or make a list over here. So the hypotenuse is actually what we're looking for. We know the opposite is 231, and we know the angle is 67 degrees. Hypotenuse and opposite sounds like sine again. So the formula is the sine of A is opposite over hypotenuse. A is 67 degrees. The opposite is 231, and the hypotenuse is X. Punching the sine of 67 into our calculator, we're going to get 0.9205 is equal to 231 over X. Our little trick comes into play. We put this over 1, and we cross multiply. These two guys equal these two guys. So 0.9205x is equal to 231 times 1, which is 231. To get the x by itself now, we are going to divide both sides by 0.9205. These cross out, and it doesn't say what decimal, so I'm going to choose 1 to the nearest tenth, 250.9 meters. Our last question in 2.5 deals with another Regina building. It's the Legislative Building on Westcana Park. And it says a person leaves the front steps of the Parliament building in Regina, walks 35 meters north. So north in the Parliament buildings is actually straight down this way. So they're going to walk 35 meters north, and they're going to turn to the right and walk east for a while and stop. Now you have to imagine yourself standing here and looking this way. Which way is the right when you're looking that way? It's going to be this direction here. So they walk for a while and then they stop. The angle between his original path going north, so here's his original path going north, and the line that connects where he stops So where did he stop? He's right here. We need to find the line that connects where he stops in the front steps. And that's going to be right here. And it says the angle between this original path and the line where he stops is 50 degrees. So right in here, this angle is 50 degrees. How far is he now from the steps of the Parliament building? So if he was here, how far is he now from the steps of the Parliament building? That's going to be an x. And we know that he walked 35 meters north, which is right there. Let's label our triangle then. Here's the right angle, assuming that north and east are at right angles to each other, which they are. Here's the hypotenuse. Here is the adjacent. My diagram's getting a little squishy. And then I know the angle is 50. So let's fill in what we know. We know that 50 is the angle. We know that 35 is the adjacent, and x is the hypotenuse. Using our SOHCAHTOA, so again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent, SOHCAHTOA. We want something that has an adjacent and hypotenuse in it, and that's going to be cosine for a change. So let's write down a formula for cosine. Cosine of A is equal to adjacent over hypotenuse. Instead of writing angle A, we're going to put 50 degrees in because that's the size of our angle, and our adjacent side is 35, and our hypotenuse is x. Using our calculator, without the shift or the sign button, we are going to get the cosine of 50 is 0.6428, and that equals 35 over x. Our little trick now is to put this over 1 and to cross multiply. And again, cross multiply means that these two guys multiplied together equal those two guys multiplied together. So 0.6428x is equal to 35. Your job is to get the x by himself, which means we're going to divide both sides by 0.6428. Oops, 28. Cross those out. When we divide this, and it doesn't give us what decimal we need to give our answer to, so I'll give it to 1, we end up with 54.5, and that would be meters. So again, that means that if he was to stop here, it would take him 50.5 meters. And that's the distance back to the front steps.